Emulsion is again a biphasic liquid process form. So in which again this is also thermodynamically unstable. But here two insoluble liquids are there. Two insoluble liquids are mostly water and oil. So oil and water. So oil is not soluble in the water. अगर आपने कुछ ऑयल लिया और वाटर में डाल दिया तो वो सोल्यूबल नहीं हो जाएगा. वो क्या होगा, वहाँ पे ड्रॉपलेट बन जाएंगे उसके. तो अगर आपने इफ यू टेक अ स्मॉल अमाउंट ऑफ ऑयल एंड वाटर एंड इफ यू ट्राई टू मिक्स इट, so by stirring, so initially it will mix, it will form a small globules, but once you stop the stirring, जैसे आपने स्टरिंग रोक दिया, क्या हो जाएगा, वहाँ पे जो ऑयल्स के ग्लोबुल्स है दे विल बी अट्रैक्टेड विथ ईच अदर एंड देयर विल बी सेपरेशन ऑफ अगेन टू फेजेस. इफ यू ट्राई, अगर आपने ऑयल ले लिया और उसका वाटर ले लिया, दोनों को मिक्स किया स्टरिंग के साथ में, तो इनिशियली वो मिक्स हो जाएगा, but because of that sharing force, because of that stirring, but if you stop stirring it will again will be separated, so that's why they are immiscible. Now oil can be dispersed in the water by using emulsifying agent. So emulsions are nothing but the liquid dosage form in which two immiscible components are formulated by using emulsifying agent, which in which one is a in which one dispersed phase is dispersed into one another. Okay, and remember what the emulsifying agent do. Emulsifying agent will decrease the surface tension. Emulsifying agent decreases the surface tension. A dispersed system containing two immiscible liquid in which one is distributed throughout the other in the form of minute globules. The system being stabilized by emulsifying agent known as emulsion. तो ऑयल एंड वाटर को एक साथ रखने का काम कौन करता है, emulsifying agent. और कैसे करता है, जो ऑयल के ड्रॉपलेट होते हैं और वाटर के ड्रॉपलेट होते हैं, दे आर उनके बीच में जो सरफेस टेंशन होता है, उसके बीच में जो टेंशन होता है वो कौन कम करता है, आपका emulsifying agent. ठीक है, तो जैसे the component or phase which is relatively smaller in amount which is dispersed in the form of globules known as a dispersed phase, जैसे oil in water emulsion. So oil in water, तो oil को क्या बोलेंगे, dispersed phase, water को क्या बोलेंगे, continuous phase और external phase. dispersed phase को क्या बोलेंगे, dispersed phase और internal phase, और जो water है उसको बोलेंगे continuous phase और external phase. The component or phase in which is relatively small in the amount and dispersed into a globules known as a dispersed phase. ओके, सो एग्जांपल ऑयल इन वाटर इमल्शन. तो इसमें ऑयल इन वाटर में क्या होगा कि ऑयल क्या है, डिस्पर्स फेज है, और वाटर क्या है, कंटिन्यूअस फेज है. सो फॉर एग्जांपल नाउ अनदर एग्जांपल, द कंपोनेंट और फेज व्हिच इज रिलेटिवली हायर इन अमाउंट. तो हाई अमाउंट में क्या होता है, कंटिन्यूअस फेज. सो इन व्हिच इनसॉल्युबल कंपोनेंट इज डिस्पर्स इज नोन एज अ कंटिन्यूअस फेज, ऑयल इन वाटर इमल्शन. तो देखो यहाँ पे ऑयल क्या है, ऑयल इज अ डिस्पर्स फेज एंड वाटर इज अ कंटिन्यूअस फेज. वो ऑयल वाटर इमल्शन में, ओडब्ल्यू इमल्शन में क्या होता है, ओडब्ल्यू इमल्शन में ऑयल कम अमाउंट में होता है और वाटर ज्यादा अमाउंट में होता है. तो कम अमाउंट वाले को क्या बोलेंगे, डिस्पर्स फेज. ज्यादा अमाउंट वाटर ज्यादा अमाउंट वाले को क्या बोलेंगे, कंटिन्यूअस फेज. ओके, कंटिन्यूअस फेज और एक्सटर्नल फेज. ऑयल इन वाटर, ओडब्ल्यू इमल्शन. ओके, so here oil is a dispersed phase and water is a continuous phase. In case of oil in water, WO emulsion, water is a dispersed phase and oil is a continuous phase. OW emulsion में क्या है कि water का अमाउंट ज्यादा है, oil का अमाउंट कम है. water in oil में क्या है कि oil का अमाउंट ज्यादा है, water का अमाउंट कम है. So oil in water emulsion, oil is a dispersed phase, water is a continuous phase. But in case of water in oil emulsion, water is a dispersed phase and oil is a continuous phase. So as I have told you, there is a two type of emulsion, oil in water and water in oil. Okay, so they are known as a ट्रेडिशनल इमल्शन. तो दो तरीके के इमल्शन होते हैं, वाटर इन ऑयल एंड ऑयल इन वाटर. नाउअडेज मल्टीपल इमल्शंस आर आल्सो देयर, लाइक ऑयल इन वाटर, ओके, ऑयल इन वाटर इन ऑयल, और वाटर इन ऑयल और इन वाटर इन ऑयल इन वाटर. सो WOW ऐसा. So this is known as a multiple emulsion. So first one, how to identify the emulsion. So it is again a very important part. इसके ऊपर भी क्वेश्चन आता है. Identification test for emulsion type. There are 5 tests. First one is known as dilution test or miscibility test. Second test is known as the dye test. Third test is known as the conductivity test. Fourth test is known as the fluorescence test. And fifth one is a cobalt chloride test. So first test dilution और miscibility test. जैसे आपको मालूम नहीं कि कौन सा इमल्शन है, आपके हाथ में इमल्शन दिया है, आपको मालूम नहीं कौन सा है, तो आप क्या करो, पहले क्या करो, जाओ बीकर में वाटर लेके, तो उसमें वाटर ऐड करो धीरे धीरे। अगर वाटर ऐड करने के बाद में वो ब्रेक नहीं हो रहा है, उसका मतलब है ये OW इमल्शन। Dilution test or miscibility test. So it is stable upon unlimited dilution with water. So if OW emulsion is there, so water is a continuous phase and oil is a dispersed phase. So इसमें कितना भी water ऐड किया तो भी ये break नहीं होने वाला. So that you can easily identify whether there is a OW or W emulsion. So if it is stable upon addition of water, unlimited water, it is a OW emulsion. And if it is stable upon addition of unlimited oil, then it is WO emulsion. So unlimited water से डाइल्यूशन करेंगे, अगर वो स्टेबल है तो उसका मतलब वो OW emulsion है, अगर वो ब्रेक होता है तो उसका मतलब वो क्या है, WO emulsion. So WO emulsion will remain stable upon addition of unlimited oil, but it will break upon addition of water. ठीक है, तो OW emulsion में अगर वाटर ऐड करेंगे तो वो स्टेबल रहेगा, ब्रेक नहीं होगा। इसमें अगर ऑयल ऐड करेंगे तो ब्रेक हो जाएगा। WO emulsion में ऑयल कितना भी ऐड करो ये ब्रेक नहीं होगा, वाटर ऐड किया तो ब्रेक हो जाएगा। सो बाय यूजिंग डाइल्यूशन टेस्ट यू कैन इजीली आइडेंटिफाई वेदर योर emulsion is OW or WO type. Then second test is a dye test. Dye test, or it is known as a staining test. So you have to use one staining dye, scarlet red. इसके ऊपर क्वेश्चन आ चुका है। So in the dye test for identification of emulsion, one of the following dye is used, scarlet red. So scarlet red dye जो है इसका एक प्रॉपर्टी होता है। So this scarlet red dye is oil soluble. क्या है, oil soluble है। So it is a oil soluble. So what will happen when you add a dye in a emulsion, this dye, so whatever the oil portion is there, so whether it is a dispersed phase or discontinuous phase, doesn't matter. So the scarlet dye will be selectively absorbed by oily portion, okay, and you have to see under microscope. So if it is OW emulsion, then dispersed globules will be appear red and ground will appear colorless, because यहाँ पे oil क्या है, डिस्पर्स फेज है, तो स्कारलेटेड ऑयल में जाएगा तो ये ग्लोबुल्स रेड कलर के दिखेंगे, बाकी सब आपको व्हाइट कलर का दिखेगा, बिकॉज व्हाइट कलर क्या है, वाटर है। नाउ इफ इट इज अ WO emulsion, तो हियर द ग्राउंड विल लुक लाइक रेड and dispersed globule will look like a colorless. Now third test is a conductivity test. Conductivity test means what? So whether you know that water is a good conductor of electricity. So अगर ज़्यादा वाटर ज़्यादा होगा किसमें, OW emulsion में, तो वो क्या, वहाँ पे क्या होगा, कंडक्शन होगा इलेक्ट्रिसिटी का। अगर ऑयल इन वाटर है तो वहाँ पे ऑयल ज़्यादा होगा तो कंडक्शन क्या होगा, नहीं होगा। सो टू इलेक्ट्रोड्स आर डिप्ड इनटू द emulsion. A small neon lamp connected with the circuit fitting with metal electrodes, and those electrodes are dipped into the emulsion to be identified. Okay, now if lamp glow, अगर बत्ती जल गई तो समझो ये water in oil emulsion है, because water is a good conductor of electricity and water is present as a continuous phase. So that's why it's a good conductor of electricity. So that's why bulb will glow, lamp will glow. But if it is a water in oil emulsion, so lamp will not glow, as oil is a continuous phase, because oil is a poor conductor of electricity. Then fluorescence test. So oil in water emulsion will not show fluorescence under UV light, but water in oil will show fluorescent under light. Cobalt chloride test. So you have to soak the paper in the cobalt chloride solution and then add it into the emulsion. If that paper turns pink, that means it is a OW emulsion, and if there is no change, that means there is a WO emulsion. These are the different identification test for emulsion. तो emulsion को कैसे identify करेंगे, याद रखो ये test. They may ask you question one like this: one of the following is not a test for identification of emulsion. Type of emulsion. क्वेश्चन में आपको ऑप्शन मिलेंगे, डाइल्यूशन टेस्ट, ठीक है, डाई टेस्ट, फ्लोरेसेंस टेस्ट, और दूसरा कुछ एक अदर टेस्ट देंगे. So remember these tests. Question already. Now emulsifying agents. Classification of emulsifying agent. इसके ऊपर एक क्वेश्चन आ सकता है आपको. Classification of emulsifying agent. What is emulsifying agent? It is any any chemical that will decrease the surface tension between oil globule and water, that is known as the emulsifying agent. So they are classified into different way, either natural, semi-synthetic or synthetic, inorganic or alcohols, finely divided solid and others. These are the different classes of emulsifying agent. So in the natural you have vegetable source, those obtained from vegetable source. For example, gum acacia, gum tragacanth, starch, pectin, Irish moss. Then animal source, those obtained from animal source like wool fat, yolk and gelatin. They are also used as emulsifying agent. Semi-synthetic वाले कौन है? Cellulose. So methyl cellulose, carboxymethyl cellulose. Then synthetic surfactants. First one is the anionic. Anionic matlab those which will have negative charge. Okay. So those surfactant which are negatively in nature. So for example, this sodium lauryl sulfate. SLS is a anionic surfactant. Question इसके ऊपर आ चुका है. Okay. What is the one of the following is an anionic surfactant? Sodium lauryl sulfate is an anionic surfactant. Most of the आप जो भी शैम्पू यूज करते हो, हेयर एंड शोल्डर, जितने भी शैम्पू होते हैं उसमें ये होता है सोडियम lauryl sulfate. So whatever foam is produced in the shampoo, that is because of this sodium lauryl sulfate. Second class is ketonic. Ketonic means they will have positive charge on the, okay. Ketonic surfactant cetrimide बेंजाल्कोनियम क्लोराइड. तो यहाँ पे एनानिक कौन है, केटानिक कौन है, नॉन आयनिक कौन है, ये आपको याद ही रखना है. इसके ऊपर क्वेश्चन आता है. नॉन आयनिक सर्फेक्टेंट, they will, that means they will not have any charge on their, okay, they will not have any charge on their structure. So glycerol esters carbapol macrocol, so these are the non ionic. Okay. Then in that fourth class is polysorbate 20. So polyethylene sorbitan monolaureate, polyethylene sorbitan monolaureate, and polysorbate 60 means polyethoxy sorbitan monostearate. तो 20 क्या है, लाउरेट है, लाउरिक एसिड का 20 कार्बन आइटम होगा. स्टीयरिक एसिड पॉलीसल्फेट 60, ओलिक एसिड पॉलीसल्फेट 80. पॉलीसल्फेट 80 क्या है, 60 क्या है, 20 क्या है, आप इजीली याद रख सकते. 20 मतलब लाउरिक एसिड का डेरिवेटिव है, 60 मतलब स्टीयरिक एसिड का डेरिवेटिव है, एंड पॉलीसल्फेट 80 मींस ओलिक एसिड का डेरिवेटिव, ओलिक एसिड. तो पॉलीसल्फेट 20, पॉलीसल्फेट 60, पॉलीसल्फेट 80. नाउ नेक्स्ट इनऑर्गेनिक emulsifying agent. So in that you have milk of magnesia, magnesium oxide and magnesium trioxide. Alcohols. So in that you have carboxyls like lecithin and cholesterol. Polyvinyl alcohol are also there. Cetyl alcohol is there. Stearyl alcohol is there. Then finely divided solids like bentonite, hectorite, aluminum hydroxide and magnesium hydroxide. So you can see these are also inorganic, finely divided solids. Others like saponin and carbomas. So these are the classification of your emulsifying agents. इसके ऊपर क्वेश्चन आता है emulsifying agent का क्लासिफिकेशन. कभी कभी पूछ लेगा कौन सा एनायनिक है, कौन सा कैटायनिक है, कौन सा नॉन आयनिक है. तो नॉन आयनिक वाले याद रखो ग्लिसरीन ईस्टर्स, कार्बोपोल्स, मैक्रोपोल्स, पॉलीसॉर्बेट, दे आर नॉन आयनिक. कैटायनिक कौन सा है, बेंजाल्कोनियम क्लोराइड, सेट्रिमाइड. एनायनिक क्या है, एसएलएस, सोडियम लाउरिल सल्फेट. तो अगेन यहाँ पे आप देख सकते हो फर्स्ट कैटेगरी इज नथिंग बट द एनायनिक सल्फेट. फर्स्ट कैटेगरी इज नथिंग बट द एनायनिक सल्फेट. तो इन दैट यू हैव सोप, sulfates, ether sulfates, benzene sulfonates, then these two also. All these are the anionic sulfate. So sodium oleate, sodium permeate, sodium lauryl sulfate, sodium lauryl sulfate, then 4 benzene diodecan sulfonate sodium, sodium diodecyl. All these are the anionic sulfate, negatively charged. Then cationic sulfate is like amines and quaternary amines. Benzalkonium chloride is there. Tetradecyl methylamine, benzalkonium chloride, cetrimide, etc. etc. They are the cationic. Anionic means negatively charged. Cetrimide, ampolytic sulfate means they will not have any charge. So lecithin is there, then betaine is there. Structure is also given. It is not important. Just remember who is anionic, who is cationic. Other ingredient added in the emulsion. So to prevent the decomposition of emulsion, okay, so preservatives are added. So what kind of preservative are added in the emulsion? So you can see over here. So acid and their derivative like benzoic acid, okay, benzoic acid, propionic acid, and their salt, trihydroacetic acid. They are used as a preservative. Mostly they are used for their antifungal activity. Then alcohols like chlorobutanol, ethanol, they are used for the eye preparation, okay, as a anti preservative, okay, as a preservative. Then aldehydes like formaldehyde, butylaldehyde, they are used as the broad spectrum preservative. Then phenols, okay, lot of phenols are there. Mercurial compounds are also there, like phenyl mercuric nitrate, phenyl mercuric acetate, etc. Benzalkonium chloride, chlorhexidine salt. They are a broad spectrum preservative. Miscellaneous compounds are also there. Bromo derivative preservative. Next one is nothing but the antioxidants used in the emulsion. Okay. Antioxidant का role क्या होता है? कि role antioxidants means what? They will prevent the auto oxidation in the emulsion. तो ऑटो ऑक्सीडेशन की वजह से क्या होता है, जो ऑयली फेज है आपका वो ऑक्सीडेशन हो जाता है और वो उसका क्या हो जाता है, वो रेंसिड बन जाता है. सो टू प्रिवेंट द ऑटो ऑक्सीडेशन इन द इमल्शन you have to add this anti antioxidants. Okay, so antioxidants they are normally added in a concentration of 0.001 to 1%. एक concentration में add करते हैं. So for example BHA and BHT, butylated hydroxy anisole and butylated hydroxytoluene, tocopherol, then gallic acid derivative, etc. You can see over here gallic acid, propyl gallate, ascorbic acid means vitamin C, ascorbyl palmitate sulfate, then tocopherol means vitamin E, etc. Then butylated hydroxytoluene BHT, butylated hydroxyanisole BHA, 4-hydroxymethyl 2,6-tert butylphenol. So all these are used as a antioxidant to prevent the auto oxidation in the emulsion. Next one is nothing but the HLP values of surfactant. So we have seen in the detail what is the HLP value, who has given the HLP value, what are the different formula for calculation of HLP value in the surface tension interfacial phenomena chapter. So I am not going to repeat it again because that will take around 1 hour. We already seen that. So just remember the just remember the HLP value of few surfactants. So anti-foaming agent will have HLP value in range of 0 to HLP value in range of 1 to 3. OW emulsifier 2 to 6. Then wetting agent will have 7 to 9. Okay. OW emulsifier 8 to 18. Solubilizer 15 to 20. Detergent will have 13 to 60. इसके ऊपर काफी बार क्वेश्चन आ चुका है, so I will repeat it once. So anti-foaming agents will have HLP value in a range of 1 to 3. WO emulsifiers will have HLP 2 to 6. Wetting agent will have in a range of 7 to 9. इसके ऊपर क्वेश्चन आ चुका है. Anti-foaming agent के ऊपर क्वेश्चन आ चुका है. OW emulsifier के ऊपर क्वेश्चन आ चुका है. And detergent के ऊपर क्वेश्चन आ चुका है. Detergents will have HLP value in the range of 16 to 13. So it is known as a Griffin HLP value scale. So anti-foaming agent का कितना होता है HLP 1 to 3. OW emulsifier होता है 3 to 8. Wetting agent होता है 7 to 9. OW emulsifier 8 to 16. Detergent का है 16 to 13 to 16. Then solubilizer का है 16 to 20. यहाँ पे देखो, so less will be the HLP value, more will be the lipophilic. Please mute yourself. So remember this HLP value ranges, these are very important. इसके ऊपर काफी बार क्वेश्चन आ चुके हैं. अगेन रिपीट करता हूँ मैं. एंटी फोमिंग एजेंट 1 to 3. सो एंटी फोमिंग एजेंट मतलब ये फोम प्रोडक्शन नहीं होने देगी, तो लिपोफिलिक ज्यादा होते हैं. सो लिपोफिलिसिटी इज इंक्रीज. लेस विल बी द HLP number, less will be the more will be the lipophilicity. More will be the HLP number, less will be the lipophilicity and more will be the hydrophilicity. तो यहाँ पे देखो आप 20 के आसपास क्या है, ये सब हाइड्रोफिलिक है. 10 से लेके 20 तक हाइड्रोफिलिक है और 10 से लेके मतलब 1 से लेके 10 तक लिपोफिलिक है. ठीक है. तो एंटी फॉर्मिंग एजेंट लिपोफिलिक 1 to 3. देन WO emulsifier 3 to 8. Then wetting agent 7 to 9. Then your WO emulsifiers 8 to 16. Detergent 13 to 16. Then solubilizer 16 to 20. HLP value आपको आना चाहिए. ठीक है. Now emulsion can be made by different methods. different nowadays different equipment are used. We are not going in the details. In the small scale preparation you can use mortar and pestle. Mortar pestles को use करके भी आप emulsion बना रहे हो. You might have prepared in the your lab, so you have to take required amount of oil, you have to weigh the required amount of your gum, you have to put you have to dry that mortar and pestle and put that gum, pour the oil on that, and okay, then you have to stir that, okay, until the cracking sound will occur, and that you have to add slowly water, so you will get emulsion. Then now in the industrial scale, mechanical stirrers are there, homogenizers are there, ultrasonifier are there, colloidal mill is also there used for production of your emulsion. So ultrasonifiers, homogenizers, mechanical stirrers, they are, colloidal mill is used for the making the emulsion in industrial level. तो colloidal mill के बारे में आपको हो चुका है. Now parts of oil, water, gum for primary emulsion. So if you want to make an emulsion, how many number of parts of particular oil, gum and water you have to take. So if types of oil, examples of oil, then quantity required for primary emulsion. So अगर आपका फिक्स ऑयल है, फिक्स ऑयल मतलब क्या है? फिक्स ऑयल मतलब आपका जो खाने का ऑयल वगैरह है, so almond oil, RHS oil, castor oil, cod liver oil, so they are the fixed oil. Okay? So in that case, to make a emulsion of fixed oil, you have to take oil in a four, okay, so four parts, then water in two parts and gum in one part. So gum and water parts are the same for each and every oil. Oil part changes. Okay. ये सब कांस्टेंट रहेगा. ऑयल चेंज रहेगा. फिक्स ऑयल में आता है फोर पार्ट्स. मिनरल ऑयल जो है पैराफिन ऑयल, उसमें आता है थ्री पार्ट्स. वोलेटाइल ऑयल जो आता है, वोलेटाइल ऑयल्स लाइक टर्पेंटाइन ऑयल, सिनामन ऑयल, पेपरमिंट ऑयल, सो वन पार्ट, टू पार्ट. देन ओलियो रेजिन जो आता है उसमें वन पार्ट. सो फिक्स ऑयल का इमल्शन बनाना है तो आपको ऑयल का चार पार्ट लेना है, वाटर का दो पार्ट लेना है और गम का एक पार्ट लेना है. मिनरल ऑयल है, उसका इमल्शन बनाना है तो ऑयल का तीन पार्ट लेना है, थ्री पार्ट्स लेना है, water two parts, oil, gum one part. Okay, then if you want to make a volatile oil emulsion, then take a two parts of your oil, two part of water and one part of gum. Okay, if you want to make a emulsion of polyresin, one part of your oil, two part of your water and one part of your, remember emulsion shelf life of emulsion or stability of emulsion. Shelf life of your emulsion, stability of emulsion, that directly depends on the kinetic stability. Emulsion shelf life depends on the kinetic stability of emulsion, means the movement of dispersed phase, the movement or attractive repulsive forces, the balance between attractive and repulsive forces of the globule, that is a kinetic stability. And thermodynamic stability, means instability due to temperature change. So thermodynamic stability of emulsion is dependent on temperature, and shelf life of emulsion depends on the kinetic stability. याद रखो ये. Next one, method for preparation of emulsion. So first one is nothing but the continental method, or it is known as dry gum method. Dry gum method. Whatever we have seen in the previous slide, proportion of your oil, water and gum. So that is for this continental method or dry gum method. So 4:2:1 oil water gum ratio. Okay. Oil and gum are there trichurate in the mortar and pestle until cracking sound will appear, and then water is added slowly in only one direction, clockwise or anti-clockwise. वैसा नहीं करना कि एक बार पहले बार clockwise घुमाया उसके बाद में anti clockwise घुमाया, so emulsion will break. So you have to apply shearing stress in one direction only, in a direction only, that only. That is a dry gum method. Now English gum method or wet gum method. Another method, mucilage of gum with water is prepared first and then oil is added and mixed uniformly to get a emulsion. So third method is a bottle method or Hobbes method. So method for extemporaneous preparation of emulsion from volatile oils. Question इसके ऊपर आ चुका है. So one of the following method is utilized to make a emulsion from volatile oil. That is a bottle method. So method for extemporaneous preparation of emulsion from volatile oil. So powder acacia Gum, that is gum. Gum is powdered and placed in the bottle. Two parts of oil are added. Bottle is thoroughly shaken, and you have to then add equal volume of water so that oil will be okay. Volume of water, and to that oil will be added and shaken. So it is not stable for viscous oil. It is only stable for volatile oils. Bottle method or Hobbs method. The next one is auxiliary method. Emulsions are prepared by one of the above method is passed through a homogenizer to get a uniform globule size. To get a globule size of 5 micron or less. It is not useful for emulsifying the emulsification of emulsion containing high solid. Auxiliary method. ये सब जो मेथड है ड्राई गम मेथड इंग्लिश गम मेथड बॉटल मेथड it is outdated method. They are not used. In situ soap method. Calcium soap they are used for making the emulsion in situ soap. In micro emulsion means what? Thermodynamically stable, optical transparent isotopic mixture और तो माइक्रो इमल्शन में क्या होता है कि माइक्रो इमल्शन will look like a solution only. So by naked eyes it will look like a solution, but if you check that solution under microscope then you can see, so it is a emulsion. So micro emulsion in which globule size in a micron, so you cannot see that by naked eyes. So that's why this micro emulsion is thermodynamically stable, it is optically transparent, it is isotropic mixture, or by basic OW emulsion stabilized with the surfactant. So it will have a size range in the 1000 angstrom unit, that is nothing but the 10 micron, 1000 angstrom unit to 100 angstrom unit. So 10 micron to 1 micron, that is a micro emulsion. So emulsion instability कैसे होता है? So symptoms of instability in the emulsion. So you can see over here, ये आपका normal emulsion है. Now there are different types of instability in the emulsion. First one is a flocculation. Second one is a phase inversion. Okay. First one is a flocculation. Second one is a coagulance. Okay. And third one is a phase inversion. And lastly, breaking of emulsion. I will explain it one by one. So emulsion क्या है आपका? So liquid droplets disperse in the water. Okay, that is emulsion. Now what happens? So if the attractive forces of liquid droplets, if it dominates uh, the the barrier provided by your emulsifying agent, then what will happen? So one droplet will be attracted to another droplet, and there will be formation of floccules. That is known as a flocculation. Now, if the density of these floccules is more than water, then there will be downward creaming. ये नीचे से लो जाएंगे. If density of these floccules is less than water, then there will be upward creaming. Creaming is nothing but the primary instability. Creaming is reversible. Flocculation is also reversible. Creaming के बाद में cracking होता है. Cracking और breaking. Phase inversion means what? Suppose आपके पास OW emulsion है. OW emulsion. Phase inversion means क्या? So inversion of phase means completely change in the phases. Dispersed phase will become continuous phase, and continuous phase will become dispersed phase. That is known as phase inversion. So if you increase the temperature increase किया आप emulsion का, there will be phase inversion. So if it is a OW emulsion, it will become WO emulsion. That is a phase inversion. Coagulance means what? Formation of attraction. Coagulance means what? So globules will be attracted and they will form a larger size globule. That is a coagulance. Coagulance. After that coagulance, there will be breaking of emulsion. These are the different types of emulsion instability. We will see it one by one. इसके ऊपर क्वेश्चन आते हैं instability in the emulsion. First one is a coagulance. Coagulance or it is a irreversible type of instability. याद रखो, coagulance is an instability which is an irreversible type. So aggregation of oil globules on the surface of emulsion because of the temperature or viscosity change. So it's a starting stage of your instability. That is a coalescence. Okay, coalescence means irreversible type of instability. Now second one is a flocculation. Remember, flocculation is a reversible type of instability. Question आता है, one of the following emulsion instability is a reversible or irreversible ऐसा. Now formation of floccules due to increasing the ionic strength of electrolyte used for the de-emulsification. So if emulsion आप है उसमें आपने ये ऐड किया electrolyte. So due to formation of floccules is due to increasing in the ionic strength of electrolyte for de-emulsification. High internal phase volume is that a tight packing of dispersed phase can increase the flocculation. Another reason high internal phase volume. तो अगर ज़्यादा ऑयल का वॉल्यूम है वाटर से तो वो क्या होगा फ्लॉकुलेट करेगा. So flocculation is reversible, remember. Then actually third should be creaming and after that should be cracking. Okay. So cracking is irreversible. Remember irreversible कौन सा है coalescence and cracking. ये irreversible है. जो flocculation है reversible है. creaming भी होता है ना वो भी थोड़ा सा irreversible होता है. And cracking means of coalescence of dispersed globule and separation of dispersed phase as a separate layer. Redispersion cannot be achieved. So cracking may result because of the different reason. For example, addition of emulsifying agent of opposite type. जैसे मान लीजिए कि आपने एनानिक सरफेक्टेंट यूज करके इमल्शन बनाया और उसमें अगर कैटानिक सरफेक्टेंट डालोगे तो इमल्शन क्या होगा क्रैक हो जाएगा. So addition of emulsifying agent of opposite type or decomposition or precipitation of emulsifying agent. जैसे माइक्रोबियल ग्रोथ होता है ना माइक्रोबियल ग्रोथ के कारण क्या होता है emulsifying माइक्रोब उसको डिस्टर्ब कर देते मतलब डिकम्पोज कर देते. सो डिकम्पोजिशन और precipitation of emulsifying agent. Addition of common solvent in which emulsifying is also soluble. If common solvent means solvent in which emulsifying is soluble, emulsifying agent is soluble. Because of the microbial action, incorporation of excess of dispersed phase, these are the reason for cracking. One more thing is very important. ये line important है. इसके ऊपर as it is question आ चुका है. If phase volume ratio concentration of dispersed phase exceeds 74%, then the emulsion will have a tendency to crack. इसके ऊपर क्वेश्चन आ चुका है. I think GPAT 2021 में आया. If phase volume ratio exceeds 74%, मतलब किसी एक पेज का 74% अगर से जाता है एक पेज तो क्रैकिंग हुई है. If phase volume ratio concentration of dispersed phase exceeds 74%, then it will result in the cracking. This was question in GPAT 2020. Next is a creaming. Again, creaming is a reversible instability. Formation of layer of relatively concentrated emulsion. It can be reversed by just by shaking. Globules will be redispersed. Now cream will occur on the top if the oil globules are less denser than water. So if it is more denser than water, the creaming will be at the bottom. Creaming can be minimized by first reducing the mean size and size distribution of globules, or by increasing the viscosity of continuous phase, or by storing the emulsion at a cool place. You can minimize the creaming by these three. Now fifth instability is a phase inversion. मैंने बोला है आपका अगर OW emulsion है OW, if you increase the temperature, what will happen? Water will be evaporated. OW emulsion will be changed into WO. That is known as a phase inversion. So reversal of emulsion type is known as a phase inversion. So change in the OW emulsion into WO emulsion or vice versa is known as a phase inversion. इन्वर्जन मतलब अपोजिट होना. ठीक है, इन्वर्जन क्या है अपोजिट होना. तो नॉर्मली आपके पास मान लीजिए कि WO इमल्शन है ऑयल एंड वाटर, ऑयल इन वाटर. फेज इन्वर्जन होने के बाद में क्या होगा उसका वाटर इन ऑयल बनेगा. सो रिवर्सल ऑफ इमल्शन टाइप इज नोन एज अ फेज इन्वर्जन. तो होता है फॉर एग्जांपल इनफ कैल्शियम क्लोराइड इज एडेड टू ए OW emulsion stabilized by sodium soap that leads to phase inversion. Okay, then okay, so most stable range for dispersed phase concentration 30 to 60%. ये इसके ऊपर भी क्वेश्चन आ चुका है. So one of the following percentage range for dispersed phase is the most stable emulsion will be obtained. तो यहाँ पे देखो 30 से लेकर 60% तक अगर आपका डिस्पर्स फेज है तो वो इमल्शन स्टेबल रहेगा. लेकिन if dispersed phase crosses 60, so in the last slide we have seen 72%, 74%. that results in the cracking. If more amount of disperse phase is added, there are chances of phase inversion. इसके ऊपर भी क्वेश्चन आ चुका है. So more stable range for disperse phase, the phase concentration is nothing but the 30 to 60%. If more than this phase concentration is added, then it results in